Okay, before we integrate something that looks like number 1, I have to teach you a little algebraic trick to rewrite it in a different form. And it's called decomposition of fractions or partial fractions. And what we're going to do is we're going to rewrite 5 over x squared plus x minus 6 as the sum of two different fractions, where the denominators are the factors of the bottom. All right, so the first thing I want to do is just factor that bottom part. And this method will be used anytime you're trying to integrate something that you can factor on the bottom. So how do I factor x squared plus x minus 6? X plus 3 and x minus 2? Okay. So basically, what you're telling me is that 5 divided by x plus 3 times x minus 2 would equal some number over x plus 3 plus another number over x minus 2. Like all throughout algebra, you've learned to take this, when you are adding fractions, to find a common denominator and to simplify it. All we're doing is we're going the very opposite direction. We're starting with the found common denominator, and we're trying to break it up into two different parts. So you always break it up into some unknown number over one factor plus some unknown number over the other factor. All right, now to solve for a and b, what we're going to do is we're going to clear off the fractions. And the way that you clear off the fractions is that you multiply by what would be the common denominator of this. So the common denominator of this entire equation would be x plus 3 times x minus 2. And I promise you're going to think this is really easy. So I'm just going to multiply everything in that equation by x plus 3 times x minus 2. So when I multiply the left side of the equation by x plus 3 times x minus 2, what am I left with? 5, yeah. And then when I multiply the first term of the right side by x plus 3 times x minus 2, what happens? Yeah, you get a times x minus 2 because the x plus 3's cancel. And then I'm going to get plus b times x plus 3. Okay, now to solve for a and b, I'm going to pick strategic values for x. And by picking strategic values for x, 2 would be a strategic value for x here. So because when x equals 2, this parenthesis becomes 0, right? So when x equals 2, this entire equation is going to be 5 equals 5b. Y'all cool with that? So b equals 1. All right, what would another strategic value for x be? -3. I'll catch on quickly. All right, so when x equals a -3, I'm going to get that 5 equals -5a. So a equals -1. So therefore, this entire thing that I started with, 5 over x squared plus x minus 6, is the same thing as a, which is -1 over x plus 3 plus 1 over x minus 2. Okay, good question. You can pick any values you want for x. Like if I picked x equals 0, then I would still end up with, I would get rid of my x's, but I would still have an a and a b. And then if I picked, say, maybe x equals 1, I'd still get rid of the x's and I'd still have an a and a b. And then it would cause me to have a system of equations with a and b. But if you pick those strategic values of x's, then you skip that step of having to have a system. So, and if you don't believe me that this is the same thing, find yourself the common denominator, and I promise you'd get back to 5 over x squared plus x minus 6. Okay, now the reason this is helpful is that we can't really integrate the original problem, 5 over x squared plus x minus 6. A lot of times when we have a denominator, we would want to let u be the denominator and hope that it turns into a natural log. but the derivative of x squared plus x minus 6 is 2x plus 1, and I don't have that. But could I integrate negative 1 over x plus 3? Sure, that's a natural log integration because the derivative of x plus 3 is 1. Okay, we'll get to the actual integrating part in just a second. Okay, so the first step is always to factor the bottom. X minus 3, x plus 1. Okay, so the x minus 11 over x minus 3 times x plus 1 will equal something over the first factor plus something else over the second factor. And it does not matter which order you put the two factors in. Like you may have factored it into x plus 1 and x minus 3, so you may have written a over x plus 1 and b over x minus 3. If you did that, you would just get opposite values that I did for a and b. Whatever I got for a, you'd get for b, but it all worked. The final answer would be the same. You'd have the same thing on top of x minus 3 and the same thing on top of x plus 1. Okay, so I'm going to go through and I'm going to multiply everything by x minus 3 times x plus 1. X minus 11 equals a times x plus 1 plus b times x minus 3. And the fact that I have an x on top of my original problem it works the same way. All right, what's one strategic value of x? Negative 1. You always want to pick the two values of x that make your parentheses equal to 0. All right, well, if x is a negative 1, then on the left side I actually have negative 12 equals negative 4b. So b equals 3. Okay, what's our other strategic value of x? 3. 3 minus 11 is negative 8 equals 4a. So a equals negative 2. So I let, the a was what was over the x minus 3, so negative 2 over x minus 3 plus 3 over x plus 1. All right, so on number 3, we're actually going to integrate it. Are y'all ready to decompose it into your partial fractions by yourself? Yeah. Okay, ideally you're doing this on your own and like maybe checking it but not copying it. nice. Okay, y'all okay with this turning into 1 over x minus 3 minus 1 over x minus 2? Okay, you may have gotten negative 1 over x minus 2 plus 1 over x minus 3, but it's the exact same thing. Okay, how do you integrate 1 over x minus 3? Natural log of x minus 3, because whatever's on the bottom, the derivative of that is exactly on top. Same thing with 1 over x minus 2. But you do need to put the arguments in absolute value, because remember, when you introduce a natural log, you have to do absolute value. Don't forget the plus c. All right, I am totally okay with that answer right there. The back of the book is probably going to use one of your natural log properties and write this as the natural log of x minus 3 over x minus 2. And you can either put absolute values around both the top and the bottom, or you can just put one set of absolute values around the whole thing. If you don't want to, then that's fine, but I'll take off. I have really good hearing.